Hello, big data enthusiasts. I hope everyone's able to hear me. Please use the chat window to communicate with us. So welcome to our introductory session. This is session 1 of our 11-part course for Big Data and Hadoop. My name is Anjana and I am part of the team at No Big Data. I will take a few minutes of your time to take you through what to expect of this session and to introduce you to No Big Data. Please make use of this time to send in a quick one-liner introducing yourselves. This session is about 3 hours long. The first half will focus on what big data is and why it is relevant in today's world. And the second half will focus on Hadoop architecture. There will be a 10-minute break about an hour and a half into the session. That is at 9:30 p.m. IST. Please use the Q&A or chat window that you see on the tool to introduce yourself. And for any queries that you may have, this will be your primary mode of communication with us for this session. Since this is an introductory session, we keep this open to people and have a lot of attendees, which is why everyone is muted. So our instructor will read out a question before answering it, and he will also do his best to answer all the queries that are posed. What you could do is help the instructor respond to more queries and comments by keeping your messages short and avoiding chat language, please. For those who will be joining us for the rest of the course from the next session onwards, the tool that will be used is slightly different. It will be more interactive and there will definitely be fewer attendees as well. For those who are sitting and making notes, please sit back and relax. We will mail you the presentation and recording. So before introducing big data and Hadoop to you, let me introduce you to No Big Data. So our primary focus is online trainings relating to big data and data sciences. We're thrilled to provide our course takers with instructors who are industry experts. You will see how true that is during the actual session later on today. As part of the course, we provide access to Cloud Labs, which is a cluster that you can use to play around with whatever you learn during the classes. This feature is unique to No Big Data and gives you a real feel of how things work at organizations that use big data. Course takers are also given lifetime access to our learning management system, which will include all the presentations, recordings, assignments, and project work. You will be able to use our Cloud Labs to complete a real-life project at the end of the course itself. And at the end of this project, you will receive a certificate which can be shared on social media if you wish. You will also be part of our alumni group. We like to refer to it as Knows Big Data, which will keep you posted of new job opportunities and will help you stay updated and connected. So let us move on to today's session. The instructor today is Sandeep Giri. I will let him introduce himself to you and take it over from here. Have a great session.
Hi, thank you, Anjana, for introducing. And let me introduce myself from here. And then, in the meantime, please keep introducing yourself as well, because that is far more important than our introduction. All right. So I am Sandeep Giri. I did my graduation in 2002 from Roorkee, and thereafter I worked in an interesting company called DE Shaw. I was managing a 10,000 node. I was basically working and managing the 10,000 node cluster. So Aditya, if chat window is not actually, I think what we are referring to chat window is as the QA window. So there will be questions window. You can use that one. Okay, so is my voice audible enough and my screen is visible enough? Okay, okay, okay. So at least some people are. Please introduce yourself as well so that I can understand who are our audience. And all right, great, great. All right, so let me give a brief overview about myself. Okay, so at D Shaw we built big data systems when the world did not know about it. Okay, so but though we had different kind of frameworks, our internal frameworks, proprietary ones, and we were not supposed to talk about it outside. Then I started a company called T-Bits Global. There I built a product called document management system for enterprise, various large enterprises such as L&T Power, and they use it still for their plant constructions, and it is quite famous in the construction industry. Afterwards, I joined InMobi and Amazon for some time, where I again worked on building big data solutions and products. All right. So, for example, at InMobi, I built a recommender after churning close to 200 terabyte data. At Amazon, I built high throughput systems similar to Apache, on the lines of what Apache Storm is. Right. And in last year, I founded No Big Data in April. We started formally on April. All right. So, great. So that's about me. Let me today in today's session we are going to do two things. One, understand what is big data, and then understand what are the various components in the Hadoop architecture. Afterwards, we will go into the details of, before that, we'll go into the HDFS, Hadoop Distributed File System, and then we'll talk about all other components of Hadoop ecosystem. All right, so this is a general one. Okay, so before I go anywhere, let me just go through the profiles of people in my session. All right, so we have around 23 people. Great, great. Okay, so hi Sudesh, and Sudesh is from Bangalore, and yeah, so any little more about you would be great. Hi Hanuman, please introduce yourself a little bit more. Hi Siddharth. Siddharth is from Bangalore, working in Cordis, technical analyst in Schneider Electric. Great to know you, Siddharth. All right, and hi Manjunath. Manjunath did his engineering from RV College of Engineering, Bangalore, and is working for Mindtree since 3 years. Great to know you, Manjunath. All right. Aman is it has 3.5 years of work ex and new to big data. So no worries, everybody is new to big data. All right. Most of because the technology is fairly new, hardly 3 to 4 years old. I'm a software engineer. I need exposure to big data for my knowledge. Good. That is Vivek. And we have Aditya from Accenture. Hi Aditya. Aditya has 3 years of experience in SAP, ABAP, and ERP. Great. Hi Balaji. Balaji is from Chennai but based in Bangalore. Bangalore. Great. And Vivek works at Cisco. Great. Okay. So great. We have a recruiter here. Sudhir Sebastian, who handles big data recruitment. Great. And Aman is working in finance software Bangalore. It's a Mrs. MISIS. Great, great, Aman. Hi, Deepika. Deepika is a Java developer in TCS. All right. So Jyotesh is working in IPSG system. Great. And San is working in Bangalore. Would like to explore. Great. Hi, San. Hanuman is from Rajasthan. He has completed MBA from Bangalore and currently working at Tarnia Technology Solutions as software engineer. Great, Hanuman. Hi, Suraj. Suraj works at VMware as a business analyst. Very excited to be here and more excited to learn about big data. I have 2 years of work ex. Great, great. Welcome, Suraj. Great. Right. Hanuman is an MCA, not MBA. Did I read MBA? I think I read MCA only. All right. Great. So that was introduction. Wonderful. We have got wonderful set of audience, and it is definitely going to be interesting. All right. So here we go. So what exactly is big data? What exactly is big data? What do you understand by big data? So okay, just give me your understanding of the topic, then we'll go into the details from my side. Right? So what do you understand from what do you understand by big data? So Vivek says any data which can be handled by a single processor, considering which can't be handled by a single processor considering the limitations of resources. Great, Vivek. Great. Siddharth says that trying to get useful information from large amounts of data. Okay. Okay. So big data is a noun, right? Data that cannot be held in the main memory. That is Siddharth. Okay. So there are two Siddharth, and San says it's high volume, velocity, variety of data. That's a typical IBM kind of definition. But what is it that you understand in a single line? Okay. Your own definition. I mean your own words. Deepika says that large volumes of unstructured data which cannot be processed on a single machine. Interesting. Interesting. Balaji says that any large data set that makes it difficult to analyze. Great. All right. So we have got great set of answers. So in simple words, today I have got very interesting answers from Deepika and one more person in the beginning whose definition matches with our definition quite much. Vivek. Vivek and Deepika. Great. So good. Good. Now, in very, very simple words, that's how we are going to talk. Although everybody talks about how high volume, velocity, variety, the standard definition, we'll stick to a simple thumb rule here. When your data grows to a very big size that you cannot process with the usual tools, and you require a distributed architecture to handle, when we say handle, it means storage and process. To handle your data, data can be of any form. So, last point, structured, unstructured does not make any sense because data means data. whether it's structured, unstructured, semi-structured, relational, non-relational, hierarchical, and whatever. So there are hundreds of ways of saying the same thing. So the first 3 point, out of first 3 point, very big size does not make much of a sense, because very big might mean gigabyte, or might mean terabyte, or might be uh, exabytes, right? So we're left with two things: can't process with usual tools and distributed architecture needed. No, so when we say cannot process with usual tools, what is a usual tool? Hadoop will become a useful tool in couple of years. So does that mean that we are now no longer handling big data? Of course not, right? So the most important part in here is distributed architecture needed. What does it mean by distributed architecture? Distributed architecture means that we are going to distributed architecture means that we require multiple computers to solve our problems. Our single computer system does not suffice anymore. Okay, so Ankush and Hanuman are not able to hear. Are others able to hear me? Okay, okay, all right, all right. Maybe try increasing the volume, please. All right. So it's a distributed architecture, meaning multiple computers are required. Single computer no longer suffices for these kind of processing, and that's when we say distributed architecture needed. Now, in case you give this definition, what I have given in an interview, people might not accept it. What they might be looking for this kind of definition. Okay. So we say that these are the four characteristics of big data: a huge volume, a huge velocity, huge variety, and huge veracity. These are the few characteristics of big data. All right. Now, big data could be big data because of these four virtues. Okay, or vices, whatever you want to call them. So because of either volume, velocity, or variety, we might end up we might end up using a distributed architecture for solving our problem. Okay, and and that problem might arise due to any of these three things. Okay, so volume is a huge volume of data, the data at rest, the data that is stored already. So how do you store such a huge data? That's a kind of problem that arises due to volume. How do you build such kind of storage? So, and second is velocity. Velocity means the data at the motion, the problem posed by moving data. Even though the data at rest might be very small, even though data may have a small volume at rest, but there could be hundreds and thousands of requests coming in and going, and because of which there could be high velocity. Can you give me an example where volume is quite low and velocity is quite high? Just give me one example. Okay, banking transaction, good, good. And any other? The velocity is quite high and volume is quite low. Give me an example of that kind of solution. Emails to groups. But emails to group, every email you send actually builds the storage, actually builds, consumes the storage, consumes the space. Sensor streams, okay. Sensor streams also, whatever data is coming in, the same accumulates. So every request is generating the volume of data. Give me a case where there's a lot of velocity, but the volume accumulation is quite low. Online orders, aeroplane monitoring, WhatsApp Messenger. Yes, WhatsApp Messengers is definitely a good point, but we are not sure if they're storing it. Okay, so I give you one example. Like take this case of this video call. Okay, by the end of 3 hours, there'll be a total of 1 GB data transmission from my side. Okay, to to my from my side to the GoToMeeting servers. While from GoToMeeting, it will be distributed to 30 people at least, which is 30 GB data is getting transmitted. All right. Though there is nothing stored at the end of it at the GoToMeeting server, right? Or you take another case like a counter which counts the website's hits. How many times a website is visited? This counter counts it. All right. Now, such a counter is a very good example of velocity. When there will be lots and lots of people, this counter will be hitting the server just to increase a number. How many people have visited this website? It'll just increase a number. At the end of millions and billions of requests, it will be a single integer left, right? So volume is quite low, though the system is going to handle a lot of requests coming in, lot of velocity it is going to handle. And that's what is known as the velocity, right? And on the similar line, the variety. So when we say these four factors, any of these factors, any one or two or more than two or all of them might be the cause of concern in an application, which might lead an application to become the big data problem. All right. So we have got variety. Variety means the kind of data we are going to handle. Okay, variety means the kinds of data we are going to handle. Imagine that we have got an image processing software whose role is to observe images and detect some patterns in an image. Now to detect a pattern in an image, to detect a pattern in the image, what it needs to do is, it will take a lot of time to analyze a photo, right? It will open up photo, read pixel by pixel, then form some correlation, search for some more pixel around a pixel and whatnot. So say image processing, so each image even though might be of 100 kilobyte, but processing it might take say 1 second, right? Now if you have got 1 billion of such images, 1 billion of such images means 1 billion of such images means 1 kb into 1 GB, right? Which makes it 1 terabyte of images. 1 terabyte of images might take forever to process if each one is taking even 1 millisecond, right? So in all of these cases, the only way sometimes is to make it run on multiple computers so that the time could be reduced, the transport of data could be reduced, and a lot of optimizations could be done, right? So due to the variety, say we have to process the video, or think of another problem. Say you have got 100 gigabytes of Google Maps. Okay, 100 gigabytes might be good enough space to store the whole world's maps along with their traffic statistics, right? Now if you have to find a way from one location till another location in this map, although it's like 100 GB, it's not that big a data from volume terms. It might take years to figure out the way from one point to another point. And that's when you need to build a cluster. You need to use multitude of computers and do the parallel computing to solve the problem, divide the problem, and conquer the problem, right? So the variety of the data, the kind of data we are handling contributes a lot to how it is going to process, and hence that might make our problem a big data problem. Now the fourth one is kind of, you know, IBM's brainchild, where every year they are adding more V's to the definition. This year they have added V for value also. So I don't know what all, maybe the whole dictionary will come after some time into the big data definition. But right now, let me just explain to you what they meant by veracity. And so let me try to describe that definition. So V for veracity. Veracity is something like confusion, something like doubt. We do not know whether to throw it or keep it. We do not know whether it's useful or useless. That state is called veracity, right? So sometimes when we are handling big data, say we have the temperatures of each GPS coordinate on the globe, as well as we have another set of data which contains the temperatures of all the cities in the world. Then there is another data set which says that we have temperatures of zip code. So there is another one which says the the temperature of all the zip codes, right? So we have got three set of big data and three set of datas, and we do not know whether which one to keep it or throw it. All right, out of three data set we do not know whether we have to discard someone. Okay, and even to reach to that decision that which this data set is actually a replica of what we already have. So to reach to this decision that which data set is useless and which data set is useful, you you need to process and store this data, and till that point you might have to use a big data solution to handle this kind of big data. This big data happened to be big because we we were confused. We had multiple data sets representing the same information, right? So that is what is known as veracity. Okay, that's what is known as veracity. And sometimes you might have to throw all the three data sets because all the three data sets were useless, right? So those are the few examples of big data. Make sense to you? Any questions on this definition? So if you have a question, do not wait for the slide to finish. Okay, just write your question, and I will pick up at the end of the slide. All right, because by the time the slide ends you might forget what you had in mind, right? So any questions till now? Is veracity used only to discard the dataset not relevant, or maybe at the end of the whole? See, veracity is not used. Veracity is the state of confusion. Okay, is the analysis that defines what to do with the data. Are all these three data sets useful in their own way, or all these three data sets need to be thrown at a time? So Anoop's question is, banking data is also considered big data. So, I mean, that's a very difficult call to, I mean, take. It all depends on how much is their data and what are they going to do with the data, right? Is it in terabytes? Is it in petabytes? Is it in exabytes? And which bank or what kind of bank are we talking about? Are we talking about hedge fund kind of companies like D. E. Shaw, where we had actually the big data long back? So it's all depends. And banking data should be actually a very good use case for big data, but they seem to delete most of the transaction details after 5 years, or they seem to make it archive and put it in somewhere else and no longer consume their main space. All right. So Vivek, is your question answered? And Anup? All right. Good. Any other question you have before I move on? Please feel free to write. The biggest benefit of an online session is is the ability to ask the question. Okay. In our online sessions, I get so many questions which are more than 100 times more than the physical class. Okay, I have calibrated. I mean, we did a statistics in my physical sessions when I go to various organizations to give a talk on big data and Hadoop. Same sessions, if I give it online, I get lots of questions, while in physical session I get hardly few questions, right? So so I mean, it's a useful thing to have online so that you can ask the question at your luxury. All right, and I make sure that none of the questions get goes unanswered. So please feel free to ask your question. In case I'm not able to answer it right away, I will note it down, send you an email that this is your answer. All right, good. So moving on. So how many bytes are there in a petabyte? Very quick. Okay, good, good. Rahul says 1000 terabytes. Is that right? Okay. Balaji says 1024 TB. All right. Carry on. Yep. Okay. Hari also says 1024 terabyte. Is that right? Okay. All right. All right. So Deepika, Rohini, Manjunath, Aman, everybody says 1000 terabytes. All right. So looks like that this class is the smartest so far, and none of them have got it wrong so far. All right. Now the answer is something like 10 to the power 15 zeros. All right. So answer is like uh, so 10 to the power 15 bytes in 1 petabyte. All right. Now if you this is the good way to remember it. Okay. So kilo, mega, giga, tera, peta, exa, zeta, iota, all of them are multiples. So uh, uh, each step is 1024 bytes. Okay. The next one is 1024 times the previous one. So 1024, 1 kilo contains 1024 bytes. 1 megabyte is 1024 kilobytes, and so on. Right? right? Good, good. So everybody got it correct. And a byte is a 8 bits generally and can store around 256 states. Right. So is 1 petabyte big data? So we talked about what exactly is big data, and we also talked about how big is 1 petabyte. Now, based on these two definitions, what is big data and what is 1 petabyte, can you tell is 1 petabyte big data? Yes, no, maybe. Okay, so sorry, Vivek says it depends on machine capacity, which handles the petabyte. So use the common understanding of the machine you have, and then you take a call. Balaji says that it depends though, but his inclination is towards yes. Hariprasad says not necessarily. Okay, carry on. You give more details like why in the with in what cases it may be and in what cases it may not be. Depends on type of data. That is Balaji. So Aman says, isn't that a situational? It depends on four V's. Okay, please go on, go on. The answer could be yes and no. So we want. Okay, let me rephrase my problem. So the problem statement is we want to store and process 1 petabyte of data reliably. Okay, we want to store 1 petabyte of data and and we want to do it reliably and frequently. And what do I mean by processing? Let's just take a classic case of processing, which is sorting of the data. That's all. Ordering of the data by some sort of, imagine it big text file and we are trying to sort it. That's all I want to be processing, and we want to just store this data uh, somewhere, right? Now, can you tell me? Now, all those who were a little bit confused, about whether it's big data or not, do you think if we have to sort 1 petabyte of data, does it make a case for big data? Yes or no? Sort as in we want to order this data. So now Aman says that yes, it is big data then in that circumstance. Okay. And Rahul and Hari and Vivek. Anybody else? Okay. Here we are not talking about terabyte. We are talking about 1024 terabyte. Okay. All right. All right. So if you think it carefully, you'll have to. Answering Vivek's point. Vivek is saying that in a Windows 64-bit recognizes external hard disks that are larger than 2 terabytes and are connected by USB. So it may not be a big data. So first, there is no hard disk available in the industry which can store 1 petabyte. As even the higher grade one, you have at most the 5 terabyte hard disks, which means you will still need 200 of 5 terabyte hard disk, and you cannot connect 200 hard disk into one computer. You'll require multiple computers to store this kind of data. Now, if you have to sort it, if you have to order it, then again it is going to take a long time, right? Okay, so everybody is agreeing that sorting 1 petabyte data makes a big data problem, right? So yes, most of the systems, existing system, cannot handle it so easily. Great, great. All right, now I've got a great set of audience, and so keep rocking, keep asking questions, and keep answering the questions. So so that you learn something and I have a good time. So why big data now, and what why exactly big data we are talking about? So somebody took somebody studied the growth of the data which is analog and digital. This is a classic diagram. I've taken it from Wikipedia. So it shows that the most important part is that digital storage just started expanding suddenly in 2002. It just started expanding. More and more people were generating the digital data. More and more people were generating digital data in 2002. And what is a digital data? Data is stored in Blu-ray, tape drive, mainframe servers, CDs, mini disks, portable hard disks, flash drives, and so on, right? But the analog storage, the analog is like paper, film, audio tape, and vinyl, and maybe analog tapes. Though floppy disk is counted as digital data, right? So you can see that analog storage did not expand; it remained almost the same, while digital storage suddenly exploded in 2002, and that's what people call as digital age. That was the year when I passed out from the college, so around 12 years back. So now you can imagine that the kind of data organizations are generating is huge. And also, more important than that, organizations have realized that data is not only a pain, but it also gives lot of information to us, right? We'll talk about it why and how. Now see this. So why are we talking about it now, or why did the data start expanding in 2002? The answer is twofold. First, devices became devices, and second is connectivity. Okay, devices and connectivity of things and connectivity of social network. So primary thing here is the devices. The objective of each device manufacturer was to make cheaper, faster, and smaller device every year. Every time they manufacture, the next device they're going to make is should be cheaper as well as faster as well as smaller. And there is lot of change happened. Okay, lot of innovations happened in the hardware domain. At the same time, the connectivity between things and between people became really affordable and really faster. Okay, the wireless network came into play, 3G, 4G, this that everything has come to connect the devices to other devices. Now, which led to various kinds of softwares in the industry so that people can communicate with each other. This is something this is something is quite which is the primary reason of having so much of data what we have today. Now, so we are convinced that data started generating we started generating data. And why does the data poses a challenge? Before we move on to why does big data poses a challenge, let's understand what are the components that become the bottleneck or that contributes to the processing or handling of the data. So these are the four things we all know about these. We all know about this, but let me emphasize a little bit more. Okay. So first one is CPU. Second one is RAM, speed and size, right? The third one is disk size and speed, and fourth one is network. So CPU CPU speed is something which has the flip flop. CPU has the does takes the call like conditions, if else statement, if this jump there, if that jump there, that kind of thing. It reads the information from registers from memory and then takes a call, puts the data back into registers and back into the memory. When we say memory, memory stands for RAM. Okay. And here RAM is a cumulative term I'm using for various kinds of caches, L2 cache, L1 cache, registers, everything combined together. I'm calling that RAM. So CPU reads from RAM and writes the data back to the RAM and reads the instructions also from the RAM itself. Now, now if the RAM is bigger, there'll be bigger data for CPU to process, and bigger data will be available for CPU to process, and hence there will be no there will be no gap between one processing chunk and other processing, right? As well as if the RAM is faster, the bus that goes from RAM to the CPU is faster. Then, as well as the RAM, the rate at which it allows you to read the data is faster. CPU will be able to read the data pretty fast from the RAM and process it and put it back. And that's why after the CPU, the next component that becomes the bottleneck is the RAM. Okay, though I mean the next component that contributes to processing is RAM, but important part is it's always the RAM that is generally the first bottleneck. For example, when wikipedia was launched, the first thing that becomes a bottleneck, or for that matter anybody who is launching the website, the thing that becomes scarce and a scarce resource is the RAM, not the CPU, not the disk, not the network. These come later. Okay. And generally every CPUs are quite free. All right, CPUs are fairly free. Now, third component that contributes to the processing is the disk. How big the disk you have and what speed do you have. Okay, if your disk is really faster, like SSD, solid state drive, where the read from the disk is extremely fast, your overall processing is going to be far more faster as compared to the. So whenever you are doing a computing and you have multiple computers available, all of these resources are going to be multiplied, right? Keep that in mind. Now, disk size and speed both matters a lot, because if the disk size is smaller and you're storing bigger files, then you will use multiple disks, and hence you might end up using multiple computers connected over the network, and the problem might shift towards network becoming the bottleneck, right? So all of these are the bottleneck at one point or another time, and we keep on shifting these bottleneck from one point to another, right? The only thing we cannot shift the bottleneck is we cannot shift the bottleneck from CPU. The only way we can alleviate that problem is by adding more CPUs or by adding more computers in the network, right? So whenever our data grows so big that we can't store it in the disk, we move it to the network. And if our data cannot fit in the RAM, we move it to the disk. If it further grows big, we move it to the network, and then our problems keep on becoming worse and worse every day. So, okay. So Vivek's point is that I mean, didn't get my point that CPU is fairly free. If you observe the CPU of any server you are running, or in general if you run say WordPress blog or Wikimedia or any of the standard software, okay, even though there'll be lots of users, the RAM might become full, CPU will be fairly free. CPU usage will be like 2%, 3%. As a statistics, no big data website has hardly 5% CPU usage in the peak hours, okay, though the CPU was quite quite low frequency, and there are so many users logged in concurrently. So that's the point I was trying to make. All right. So out of these four things, at least one will become the bottleneck when we process bigger data or data of huge size. Now, as a corollary of this point, when you add another computer, it comes with all of these four parts together. Network as in the data it can read from the network. That is the network. When we talk about that, what's the how fast can you read the data from the network? All right. Was he able to clear? Do you have any questions at this point? Okay, no questions. Okay, so either I am doing a pretty bad job or I'm doing pretty good job. Only then you can have no questions. All right, all right. So stay. I mean, feel free to ask your question at any moment of time, and I would love to explain. And we have ample amount of time. Nothing to hurry. Right. Yeah. So few examples of big data customers and these standard case studies. So I will just focus on the first part. That's where I have mainly worked so far. First one is the recommendation engine. This is what I built for InMobi. So what does it mean by a recommendation engine? Based on the history of the user or users, a recommendation engine shows the recommendation which should be very fairly accurate, and the user should find them very useful. Okay, that's the idea. Curated ones and recommended automatically recommended are far two ends of two ends of the things, right? Because curated is something where a selfish interest is involved of the people, or curated is one handcrafted. Okay, so handcrafted might be really great, like an artist touch, but handcrafted recommendations tend to have the idiosyncrasies of individuals or tend to become the biased based on who pays more. So a recommendation engine is something like, based on your preference, your feedback about various movies you have watched, I tell you that hey, you might like these movies. Based on the feedback you have given, based on that, I'm telling you that you might like these movies. Or based on the pages you have visited on our website, I give you the recommendation because that you have spent so many hours on this particular product page reading about it. The people who have similar behavior like yours might generally like this also. Okay, the classic example of a recommendation engine is Amazon's on the detail page. You will see you may also like these. So that is something really powerful. And interestingly, that brings a lot of sales to Amazon. That brings a lot of sales to Amazon. All right. Now, so that is something called a recommendation engine. Why does big data matter for recommendation? So the more the data you have, the more you precision would be there when we are computing similarities. The more the data points you have, the more are the chances of finding a better recommendation. Okay, if you have only 3 movies in the history and people come with those answers, say that there are only 5 people who have given the feedback on movies, then you will have hardly anything to recommend. First, second, your response, your answer will be very small. Okay, very wrong, very deviant. Okay, so recommendation engine demand that you should have big data. In case you don't have big data, then handcrafted ones might be better than the data you have on the website. Because if you have small data, the chances of this data being very skewed or very uh, to one side, to very narrow corner, is high rather than spread out across various geographies, various kind of demographies. So the most of, if your data is very small, there is no point in running the recommendation. Therefore recommendation engine makes a good case for big data. Okay, and that's probably the first thing which organizations do. They first, if they have huge data, they first build a recommendation engine, because that immediately utilizes their data, as well as that immediately gives the returns. Okay, that immediately gives the returns. And recommendation engine is something because of which lot of organizations have started capturing more and more data, right? If they did not know that there is so precision of recommendations, then they wouldn't have done. People would not store even the user's history. Now, second one is ad targeting. What does it mean by ad targeting? This is a little bit very special to few companies. So, ad targeting essentially means. So, what does a ad company do? Let me first describe it a bit. Then you'll understand. So, you have on one hand you have the inventory of advertisements. Lot of advertisers have created ads on your website and given it to you. Okay, hey, these are my ads, and if you display these ads for this much time, I'm going to pay you this much. That is what we call inventory, right? On the other hand, for a for a advertising company like InMobi or even Google, on the other end, you have the real estate as in where all you can display these ads. A real estate can be inside a mobile app, real estate can be inside on the website, real estate can be as big as the on a social network. So you have got these many billions of slots in the real estate in which the ad can be shown. Now, at every time, these all real estates, whatever, somebody is playing game, somebody is watching a movie, in the middle of it, you have to give the ad, and somebody is visiting a website, somebody is seeing a social, visiting Facebook. you have to give these ads, or somebody visiting Amazon also shows the ads. Now you have to display, you have to hand over appropriate ad to the appropriate user. The more closer your ad is, the more relevant the ad is to the user, there are high chances of the user to click on it, and there are high chances that user will not get irritated by your ads, right? If the more relevant, if that is the reason why ads, when you search for something, Google ad gives you most relevant ads, and that's the reason why people click on those ads, right? So when you do the ad targeting, it's a humongous problem. You got thousands of requests per second from the users asking for ads, okay? And on the other hand, you have got this great inventory of ads. Now which one to serve to which user is the most important challenge, and that has to be done within a fraction of um, I mean within few milliseconds. The whole processing should be within the few milliseconds, right? So ad targeting is a very, very important thing. Very important thing. So for that you need to have lot of resources, lot of computing, and because there is going to be a huge velocity, right? So that is what is known as ad targeting. Ad targeting is a big, big challenge. Lots of people are not able to handle this kind of challenge initially. Third one is search quality. Search quality is a big case, and nowadays search quality has become even tougher. Now everybody compares your search quality to Google, right? So search quality, what does it mean? You built a document management system, or you built a library management system, or you built an intranet solution for your content management. Now users expect you to provide a search, as opposed to earlier days when things were organized in folders. People used to browse around folders and pinpoint the information. People have realized that better than that is searching. I put a keyword, I get the answers. I don't have to rummage around this folder, that folder, right? So any software you build, any software you build for information management, you will have to build a search. And if you have to build a search, you have to provide a decent amount of search quality. You might think that if I'm building a internal product which is going to handle few GBs of data, why do I need a big data solution in first place? Why does it matter to me when my data is quite small, right? Why does this, why do I need to invest in big data technologies when I'm just handling few GBs of data? The truth is, first, even though your data is small today, tomorrow it's going to grow big. Second, even though your data is smaller, you will have to build dictionaries, you will have to do a lot of churning of the public data so that you can give really, really brilliant results, right? So for categorization of your information, you might have to run various kinds of algorithm, and also to build categorization of the information you have, you might require a thesaurus from a world wide web, right? So, so for example, blue dart, blue space dart and blue dart are the same words. In case you do not know this, you will not be able to give correct results. And to know this, you might have to understand the world. You might have to crawl the data from the World Wide Web and then display it, right? Crawl the data from World Wide Web and then correlate that blue dart and blue dart are the same thing, and build a dictionary which you feed into your system and categorize and recategorize the information. So what I'm trying to say is that even though your data might be small, you are just building a nice little, everybody build these KMS, RMS, IMS, and DMS, whatnot. In all of those, if you cannot provide a really brilliant search engine, then it's fairly useless. This this whole sentence, this whole claim is based on my own experience with T-bits. So I started T-bits as a nice little example, nice little product. But the moment we started handling the enterprises, which had few GBs of data, I realized that people demand search quality really really high. People earlier people had this patience of browsing through the hundreds of pages. I remember people used to open the navigations, I mean 50 navigations tab, and they could go to 10th page also in the Yahoo, when there was only Yahoo search engine or Alta Vista. But now, after companies like Google and other companies have come, or even Amazon, if you write denim in Amazon, it immediately gives you shirts instead of showing you the results from books, right? So that's what makes a strong case for search quality. Even in Tibet, lots of people demanded the search quality really high, and they were not able to figure out why is my search so bad and Gmail has got so beautiful search. So expectation levels are really high, right? And just based on this fact that your search is not great, your software might be tagged as useless software, right? That's when I sat down and built a really powerful search engine, to an extent that it could actually search in images, okay, for the document management system, so that all the users who are scanning their documents and putting it, I'm able to search, right? And they would not realize that they are actually searching in images, and they will just find their information and feel really happy that they found their information. They don't really care that what technology do you use. So a search quality is a very very important aspect when we build any software as of today. Few years back, some 20 years back, it was search quality was nobody's agenda. Everybody's agenda was to send emails out of software, right? But now it's the search quality which is the most important thing. Fourth is sentiment analysis. This is something really really useful, okay? So what is sentiment analysis? A sentiment analysis is understanding the sentiment of people, okay? And how do you understand the sentiment of people using big data? You find the public sources of the data which reflect the people's behavior, and Twitter is one such case. So you go to Twitter, you find out what are people talking about you, then figure out whether it's negative or positive, and then accumulates it and say that over a period of time our popularity is growing by this much, just quantifying the words. So you have a huge dictionary of negative positive words, you have a huge dictionary of phrases, and then you mix the two things together, take the Twitter data, and then figure out whether the sentence was negative or positive in each tweet. And then you plot a graph saying this is our overall quantified number representing the sentiment of people, right? So that's what it is. So was I able to explain what is sentiment analysis? Yes? Great. So we'll take a case of recommendation engine in our sessions, in probably ninth or tenth session, and then we will get into the sentiment analysis, a detailed sentiment analysis in one of the projects. All right. The fifth one is abuse and click fraud detection. In that you have to find out what is a fraud and what is a pattern for finding the fraud. Okay, and this is fairly well known technique. Okay, so, although the technique is known but pattern is not known. So for example, if a user comes to Amazon and suddenly starts buying really costly things, okay, now that's a fraud. Okay, they generally flag it a fraud because maybe this guy has stolen somebody's credit card. And the click fraud is when your competitor keeps on clicking on your ads so that you end up paying a lot of money and getting no customer. So if the competitor clicks on your ad, your money get deducted and is given to the advertiser. And if your competitor keeps on clicking so many, you will exhaust your budget and that slot will be available to the competitor. All right. So we will do the project based on sentiment analysis, okay, and and a recommendation engine. That was Anup's question. Okay. Now to detect that whether it's a click fraud, Google's and these all advertisers do a lot of analysis. They generally have fingerprinted that these are the cases of click fraud, and in case that repeats, there are high chances that user is doing a click fraud. If the distance between two clicks in the ad is less than these many seconds, if it is coming from the IP, if the products which it is clicking on are absolutely irrelevant, okay, absolutely two different things, there are no chance that our user if likes A will like B. In those cases it might be a click fraud, and they do it very diligently. All right. Other than that, telecommunication companies are using big data for customer churn prevention. Meaning, why to figure out why do customers leave us and avoid the scenarios due to which the customers might leave you. And that is a very, very powerful thing to happen in this world. They do a lot of statistical analysis based on the individual's behavior. How many SMS were sent, how many calls were made, how many calls were answered, how many rings were received, after how many seconds the call was answered, and what was what kind of how many email chains started with the customer and so on. So that analysis goes a very long way, right? The second one is network performance optimization. So figuring out which user is located at which place in the city and what is the traffic pattern in during the day, during holiday, during the night, and accordingly managing their capacities is something which is important, and that leads to network. I mean, if they can figure out the pattern of the usage across the globe in the geographies and in the various demographies, then they can optimize their network accordingly. Okay, they can manage their performance accordingly. They can figure out that during the day in offices area the usage of 3G network is too high. Okay, and accordingly they can optimize their performances, right? Third is calling data record analysis, figuring out various behavior of people based on their calling records. Okay, and also analyzing the network to predict failure. It's fairly possible given amount of technology we have today that given a lot of data it can automatically figure out that these are the reasons that cause the network failure. You do not have to sit and figure out by yourself. You can train the computer saying this is failure, this is successful, this is failure, this is successful, this failure, this successful. At the end you will have a great output saying, if you tell that this is the input data, it will automatically tell you whether this is failure or success. It gets trained. So those kind of technologies are fairly open and available to people like you and me, and we can utilize all those tools and techniques to build really, really smart solutions and to build really, really useful things, right? So that is few examples of big data customer. Then there is government and healthcare and life sciences. And these people, this is not something they should be doing, want to do. No, these are people are already doing it. People are utilizing Hadoop kind of solution and Hadoop ecosystems to do all of this. Okay. I have taken this information from the users of Hadoop who is doing what using Hadoop. Okay. And because that is the information available, because we don't have a general information available for other products, but Hadoop's information is fairly available. Okay. Now, this is the number of people who are using Hadoop across the cluster. Again, I have taken Hadoop because that is more quantifiable as compared to any other product. Okay. So the bigger the font, the more the number of instances, and hence Yahoo is highest, and then Facebook and LinkedIn, and maybe eBay. All right. So lots of people are using Hadoop to solve their problem. Is it clear to you? All right. Now these are the few common myths which we roam around with. First one is big data always means data above or in the range of terabyte. Okay. Sometimes even few gigabytes of data might become your problem, and you might require a distributed computing for solving those problems. So it's not necessarily terabytes and above or petabytes. No, it's even the gigabytes kind of solutions. Based on your requirement, you will realize that it's not possible to solve those problems using your existing infrastructure. And you can no longer say that we will buy a supercomputer or we will send this problem to NASA. No, you can build such a network and solve it by yourself. So even few GBs of data can lead to big data problem, right? Does it make sense to you? So keep asking the question. I love to answer, and keep it like a discussion rather than a one-way traffic. All right. Now, second common myth is it's always about social media doesn't apply to me. No. There are lots and lots of use cases everybody discovers in their own organization where a big data is generated and it's a big data problem. Will replace enterprise data warehouses. EDW means enterprise data warehouses. No. Enterprise data warehousing has its own use case. It manages the transactional data. It provides you really, really robust solution. Un- Unless, of course, your data has grown so high and your requirement in the enterprise data warehouses is particular requirements in data warehousing is such that it cannot be catered using existing tools, you might have to take that particular problem and build a solution around that using a Hadoop or any other big data solution, right? So far as per the understandings, EDW, enterprise data warehousing, as well as big data solutions will coexist because there are few things big data solutions cannot provide. One of those things is transactions. None of the big data solutions as of today none of those solutions can provide you the capability of transactions as provided by enterprise data warehousing. Okay. While the amount of huge data, unorganized data, unstructured data, you cannot handle that kind of data using EDW. For that, you require mechanisms, require computing resources, you require a lot of space. For that, the big data solutions will exist. So effectively, big data solutions and EDWs will coexist for reasonable amount of time. I do not foresee any scenarios where it's not allowed. No, I mean, I don't foresee in near future that EDW is going to get replaced. Big data is just a buzzword, no practical application. Okay, let me just accept the fact that yes, it's a bit of buzzword, but the truth is, it is the real technology. It's not like Web 2.0. It's not like your other kind of buzzwords. No, it has got substance. It has got real problems to solve. The fact that companies like Flipkart, companies like Flipkart are still not able to handle their load shows that there is a lot to be done in this whole game. The people need to learn a lot. People need to build a better tools which others can use a lot. So it's not just a buzzword. It has got real implications. It has got practical applications. This I can tell you from my own personal experience, right? Now, it's a new concept. No. As I was telling you that in 2002 I joined DE Shaw and there we were churning a lot of data. We were doing computations on cement plants to figure out the stock prices of various things. Based on cement plants, we were figuring out how is the construction industry going to go in a particular territory. What is the production rate of the cement plants? So there were a lot of things based on power, based on electricity. We were trying to figure out a lot of things. So even in 2002, people were doing a lot of big data as what is now. Okay. So it's not a new concept. It's a age-old techniques. I know it for 12 years. There are lots of people who had been doing and manipulating data for quite some time. It is just that now even a smaller companies has this luxury and access to the big data, and as well as smaller companies have luxury of access to these open source tools which can process the big data. Therefore it sounds like a new concept to all of us, as well as IBM like people are trying to market a lot. Therefore it sounds like a new concept, but this is like very important concept for everybody. Okay, whether you are Java developer and this and that. Okay, so Vivek's question is, does big data have online processing, that is real time processing, or most? No, there are all kinds of solutions. There are batch processings and there are real time processing. Okay, batch processing is something like you gave the order and forgot, and once the system finishes the work, it will send you an email saying, hey, your report is ready. That is batch processing. There is no hurriedness. The focus is on precision rather than time, right? Then another case is where it's a real time. Say, for example, the people are coming every minute onto your website and you want to see the statistics saying, is the user getting bored or is the user really active? For that, you built a solution so that it can handle hundreds of users per second. So those kind of solutions are fairly possible using tools like Apache Storm, even HBase, and even systems like Apache Spark. And these systems are fairly powerful and robust. All right. It is expensive. The answer is no. All the solutions, all the tools are open source, and the most of the technology, thankfully, is open source. Okay. Earlier, people had to buy the software from Microsoft, buy the development editors from Microsoft, and then they buy hardware also to run something, and on top of it they'll buy the books from Microsoft only. If they have to get training, they can only get training from the people who Microsoft trained, and they will charge really high. Similarly, Microsoft will certify the consultants, and only those consultants can be employed. And that would lead to a humongous amount of expenses. And and at the end of it, because of the expenses, there will be few adopters in the technology, and in a long run, that technology is going to anyway get obsolete with very few users. So that's the point. So it's not earlier that model of making everything so proprietary that people cannot use it, people cannot develop using this, is obsolete. That kind of systems cannot survive any longer. That is why all the NoSQL databases are open source as of today, right? So none of these systems are expensive. It's just the people who you recruited might be too expensive right now. That is why there is a lot of vacancies in the industry demanding for various big data solutions. Now, next one is, it's only for data scientists or is magic? No, it's for everybody and it's not magic. 10th is that we have enough hardware, do not need any more. Okay, so let me first finish the ninth point. Is for data scientist or is magic? No. Whatever, there are data scientists who are doing really brilliant jobs. But the beauty of the world today is all of that knowledge is available. All of the algorithms they have written, they wrap it in a library like Mahat, or they wrap it in a library like MLlib, and then work on it. Okay. Therefore, it's no longer a magic. It's a science, but no longer a magic. Right? Now, next one is, we have enough hardware, don't want it. It's nothing about hardware. Whatever hardware you have, you can utilize it. We will build it when we need it. That's another thing which I keep on seeing it again and again. No, it's not that way. You need to start accumulating the data now so that tomorrow you can build brilliant solutions on top of this data. You cannot say tomorrow that, hey, we did not know that you needed data to churn. No. If you need to churn the data, you need data in first place. If you need predictions, you need to accumulate data. You need to gather all the behavior of the user. Okay, the behavior of the user is not a useless data, it's not a burden. You need to accumulate now, and you need to build a platform which gives this freedom to developers so that they can log the activities properly. Therefore, you cannot right now say that we will build it when we need it. No. If you're building a solution, and in case you are interested in analytics tomorrow, try to gather as much as data you can. And only then you will be able to provide really quality service to the end user rather than irritating offers. Okay? Big data is about Hadoop. No, it's not about Hadoop. Hadoop is just one solution. It just so happens that we are covering only Hadoop right now in this session. Okay. Now I've got a question from Ankus. Ankus says Facebook also works on real-time processing and they are using big data. Yes. So I mean, if companies like Facebook work on real-time processing, they are, of course, is termed as big data. Okay, and big data is not Hadoop. So yes, they have to do the real-time processing. Otherwise, they won't be able to provide such a humongous rate of rate of status updates. Okay, so lots of people think that for Hadoop, you require special hardware to run, or for running MongoDB, you need special hardware to run. You need to buy blade servers. No, even the machines which is there at your home for playing computer game, or even a little bit older hardware, is sufficient and good enough for running Hadoop and these kind of solutions, all of these solutions. So it is not required to have a huge RAM, use this, use that. That is the beauty of distributed computing. All right, a data node I will talk about these things later. You will understand what does it mean more. It's only few companies and few solutions that demand a higher hardware. Say for example, SAP HANA. They are very costly solutions. They are bundling a hardware and the software together, and that makes it costly. But good news is they are not the only definition of big data. Big data is characterized by distributed computing, and they are just one small player in the market. Okay. All right. Is SAP HANA for big data? They claim it to be, but a computer on a RAM based, who is a solution which is RAM based, is which is uh, which will be able to handle as much as data as it can fit in the RAM, cannot be termed as big data. Okay, but I'll not counter that point. Let people decide by themselves. All right. So SAP HANA, they claim it to be a big data solution, but it's more like an analytic solution. It's a really brilliant solution, no doubt about it. All right. Okay. So Hari's next question is, which is better, Hadoop or HANA? They are two different solutions for two absolutely different problem set. Hadoop is great when you are okay with a little slower processing, but processing humongous data, hundreds of terabytes of data, 200 terabytes of data. That kind of data, if you have and you want to process using Hadoop, then it's great. But in case you have smaller data, say 100 GB, okay, 100 GB and 100 terabyte is 1024 times, right? So so if you have that kind of small data, but what you want is you want a really, really faster processing of this data. Say you have to do a standard deviation of 1 GB records. HANA will be able to do it far more faster than Hadoop. Okay? Or Redis. Redis is a similar solution. Will be able to do it far more faster than any other solution. And that's what makes HANA important or Redis important in the game. While Hadoop has its own properties. Hadoop provides you a batch processing, although there are now more components into Hadoop architecture. They provide a complete solution to the problem. Right? Was I able to explain, Hari? Great, great. So now is 9:33. I think we should take a break and come after 10 minutes. All right? Okay. Now let me. So we'll be back by 9:44 p.m. IST. Okay? Hey guys, I'm back. Should we start? All right. So, so Amit, actually, there was a enter pressed in this slide. That's why there was basically empty line, which became the fifth point. So Amit's question was there was no, like it was like this. So there was no fifth point actually, but it was enter pressed here. All right. Okay. So, oh, that was Aman's point actually, not Amit's. All right, so we have discussed about 11 common myths, and these are the few jobs. Uh, I mean, I did a little bit of data churning from the job portals, although this is fairly old, but it is still very relevant. Okay, so the number of jobs in big data and Hadoop is quite high, as you can see, and the salary ranges, you will see that the blue one is for Hadoop and red one is for Java. So as you can see, most of the jobs, percentage of jobs is quite high in Hadoop when it comes to the higher salaries, which shows that the salaries are quite high in case of Hadoop as compared to Java. How do we see security around big data and Hadoop? Security, as in what kind of security are you talking about? Security from the software end point of view, or are we talking about job security? Or so Rohini's question is, how do we see security around big data and Hadoop? So I want to understand a little bit more. Yes. With respect to information security perspective, yes. So few years back when these softwares came into play, the system was based on the assumption that only the trustworthy users get into the network. But as of today, it is it is fairly secure. The fact that we are able to run our labs, Hadoop labs, without too much of fear of attack, and that itself shows that the tools are fairly stable and secure as of today. But the general security principles of infosec applies here. Okay. The other thing is that most of these tools are written in Java, so the Stack Overflow and the other traditional ones which caused main which opened up main security vectors. I mean the attack vectors, main attack vectors, those are not there. All right, specifically in case of Hadoop, right? But you can never prove that it's a secure thing. You can always prove that something is unsecure. All right. So, few years back, it was not meant to be such open because it assumed that all the participants in the network are trustworthy. Now that assumption is no longer valid. Also, from the analytics report in Gartner Top 10, the technologies point number 1, 4, 9, and 10 are tangentially pointing towards big data. Same is the case with Forbes. So effectively, it's quite important to learn big data and Hadoop. First, there is a demand. Second, there is a substance. It has a practical implications. Okay, and there is a fourth is there is a decent amount of technology involved when we are dealing with distributed computing. There is a multiple softwares involved, there are multiple tools, multiple programming languages involved, so it makes sense to learn this technology stack. All right, so let's start with what is Hadoop. Okay, and please feel free to stop, ask any question even when I'm in the middle of slide. Okay, so Rohini's next point is especially when large data residing in different places or locations. So availability and integrity, are there any tools for these? Are there any tools for these at present? Okay, okay, that's a very good point. So yes, so large data residing at different locations or places. So they definitely, it makes a case of availability and integrity. And that's where tools like Hadoop actually come in. They try to think availability from a different angle. In around 10-15 minutes, you will learn that availability part has been fairly eliminated. Availability as a problem is no longer there, but integrity might become a problem. Is a problem with the uh, like the way it is in another software. It's also there in case of Hadoop. All right, now, so the other thing is that most of the components in the ecosystem of Hadoop, they are, all of them are network services, right? And when there are a lot of network services, there are high chances it opens up a lot of attack vectors. So definitely it poses information security challenges, but they are very well covered so far. All right, and most importantly, the communication protocol from one Hadoop to another Hadoop instance is via SSH, which is fairly secure. But if user make a mistake while configuring things, they might open it up for disaster. All right. So that's a situation of Hadoop availability and integrity. And specifically tool I haven't seen in as a part of Hadoop ecosystem. None of the tools which are part of Hadoop ecosystem cater to the information security specifically. Okay, maybe there is a need for one. Okay, all right, all right. Now, what exactly is Hadoop? Hadoop is a suite of components as of today. Earlier, it was just two components based on Google's papers. Google published three papers earlier. First one was Google File System. So, and second one was MapReduce. Based on those papers, dog cutting implemented Hadoop. And why did they do that? Because they were working on a hobby project for a search engine. They call it Nudge. Okay, and when they started doing it, then when they wrote the crawler, they realized that it's not that easy a game. It's a quite difficult one, specifically storage. And in the meantime, the Google published papers and they just took an inspiration and built Hadoop first before building Nudge. Now, Hadoop is basically a toy elephant. The name of the toy, mm, okay, the name of the toy was Hadoop, and that toy was dog cutting's kid was playing with the toy. And as of today, Hadoop is not only limited to those two components, or those basic three components. Hadoop is actually a suite of more than 13 components as of today, which are under the umbrella of Hadoop as of today. Okay, so Hadoop is essentially a framework to handle big data, and all the components that lie under the umbrella of Hadoop are reliable, scalable, and are for distributed computing. Okay, so, so now before we move on, let me discuss what are the various components of Hadoop ecosystem. Okay, so these are the basic systems of basic components of Hadoop ecosystem, right? So at the bottom, the most important one out of it is Hadoop distributed file system. Hadoop distributed file system is something which gives you an enormous amount of storage and is the common for almost all the components. So Hadoop distributed file system is the one where everybody is going to store their data, and right, everybody is going to store their data, whether it's HBase, whether it's Hive. All of the components, they depend on HDFS, Hadoop distributed file system. And there are these, to start with, there are these import export tool. For importing the unstructured data, you have Flume, and for importing the structured data, you have Scoop. Scoop essentially imports the data to and fro from a relational database. And on top of Hadoop distributed file system stands something called Yarn. Yarn is something that makes it possible to do the computation on multiple nodes. Okay, and and here in the Yarn, the most important feature you will notice is taking the computation to the data. Since this Hadoop distributed file system going to exist on multiple computers simultaneously, Yarn is going to run the computing near the data. And on top of Yarn, there are various programming frameworks. Programming frameworks such as MapReduce is one paradigm of programming, Spark is one, and there are more and more which are coming in. On top of HDFS and related to Yarn is your HBase. HBase basically stores its data onto HDFS. HBase is the database which makes it possible to store billions of rows and by billions of columns without any problems at all. Okay, if you want to have a humongous data in the form of table or in the form of semi-structured, you can store it in HBase. And HBase under the hood will be storing data in files, and that is in Hadoop distributed file system. Then you have Hive. So whenever you have to do the computation, you had to earlier write MapReduce. You had to write MapReduce code to do the computation, and that was very clumsy because even for a simple where clause, if you are writing Java code of 100 lines, it's simply stupid. It doesn't make any sense. And that's when things like Hive came in, where you write the code in a program in a SQL kind of query, SQL query, standard ANSI SQL, and that gets converted under the hood into MapReduce and other paradigms. User does not need to know the Java programming to learn Hive, and that's what exactly is the use case of Hive. Hive is like your SQL interface to your data on HDFS or HBase. Okay, now next one is Pig and Pig Latin. Pig Latin is the language, Pig is the framework. Pig is similar to Hive, just that it's a new language. People realize that SQL cannot scale up to become a real distributed programming language, a query language. Therefore, they coined something like a Pig. Pig is based on standard tuple algebra and is really, really useful. Okay, I love it, and all the users, who all the students have seen in past, they end up using Pig instead of Hive? Can we take HBase out of Hadoop and use it like MongoDB? That was Sampath. Thank you for that question. Very good question. So HBase is NoSQL database, but it specifically works only on HDFS. Okay, it doesn't make it's not possible to use HBase elsewhere. Without installing Hadoop, if you want to use HBase, that's not possible as of today, and that is as per our own knowledge. All right. And that's the reason why people use things like Cassandra sometimes when they don't want to install Hadoop. Okay. Hive and Pig are different. Yes, that was Vivek's question. Yes, they are different. Pig is a different kind of programming language, and Hive is a standard SQL language. But Hive is very closer to Pig is very closer to SQL, but in a very neat format. You do things step by step rather than nesting the queries. Okay. If somebody asks me in a single sentence, how do you define Pig? Pig is a better SQL where you don't have to nest queries. Instead, you can do step by step assignment and use those as set based tuple algebra. So I like Pig very much, and students also seem to like it very much, right? And the other thing, the other difference is where you see is that's correct. One is for structured and other is not. Yes. So Hive is basically makes it possible to churn unstructured data, right? Hive also makes it possible to churn structured data, but for that you need to do a lot of a little more effort. While Pig has been designed bottom up for big data, Pig has been exactly designed for distributed computing and unstructured data. Now, out of all of these, there is a guy called Mahoth. Mahoth is a library of tools, okay, library of algorithms. The things we talked about, like like for example clustering, pattern recognition, training, and recommendation engine, they are standard library functions. You can straight away use it by providing it the data in the format it expects, and it will give you the output such as recommendations without you knowing what how exactly it generated those recommendations. And that is the beauty of Mahat. Now, the next guy in it is Uzi. Uzi is an important component. It's a workflow engine which connects, because when you think about the whole solution, when you are working on a project, so you will start with importing your data, some via Flume, some via Scoop. Then you will structure it and clean it and keep it somewhere using your MapReduce jobs. And some of it might be in Pig or Hive. And then you will be generating some insights using Mahat. So there will be at least 10 steps, 10 different programs to be executed, right, on your data. And that you have to do it every day. For that, Uzi is the best solution. Uzi basically ties them all together, just like Apache Ant, right? Good. And we interact with these components using command line, Java, or any programming language like Python. How Cassandra and Zookeeper related to Hadoop? So, Cassandra and Zookeeper are related to Hadoop because they qualify in their definition like their definition says any software which is reliable, scalable, and for distributed computing is acceptable by Hadoop guys. So Cassandra and Zookeeper, they actually are reliable, scalable, and for distributed computing, and they asked. Yeah. So yes, Siddharth, I'll be Siddharth's question is Siddharth has missed last 10 minutes. So, yes, we will be sending you the slides as well as the video. So, nothing to worry and just focus on things from now onwards. All right. Okay, then. So, moving on. Now, the real question to you: if you have 100 terabyte of data, how are you going to store it? If you have 100 terabyte of data, what are you going to do to store it? How are you going to store it? Any solutions, any literal thinking solutions out of the box or in into the box or howsoever, whatever you think, you have to say build a common movie storage where your whole community living in the same building can store the movies and watch the movies from. So you have to build this kind of storage, and your estimate is that you will need 100 terabyte of storage. What are you going to do? Anybody? Just any ideas? I'll wait for some time, don't worry. You comfortably write your solution. So idea is that you live in a community, you realized that your neighbors and friends, they need to store and watch movies, and whenever there is a new movie comes in, somebody puts the movie into this network and people watch it. Now, what could be the best solution? Or you can actually better correlate with the hostel. In the hostel, you have 300, 400 people living, and you want to build this common entertainment storage where people store TV series, movies, and music and everything, and which comes to around 100 terabyte. How are you going to build this storage? Your architecture. So Vivek's solution is across multiple nodes which are interconnected. Okay, across multiple nodes which are good point. A little more details if possible. Balaji is saying that use 25 into 4 terabyte hard disk. Good. Okay. Answer typically over Sampal's answer is typically over SAN or NAS, which has better read speed. Good. And Siddharth is saying use NAS, network attached storage. Any other? Just any solution which comes to your mind. Distribute 100 terabytes into equal nodes. Okay. Just feel free to answer in your own way. This is very important. This will make you think that what is so difficult about 100 terabyte storage. Use Dropbox, but if you think about this, you Dropbox will give you few GBs, right? Around 15 GBs, which means 100 into 1000 divided by 15, which is 7000. 7000 Dropbox account you will need, right? And moreover, Dropbox is something. If you're an engineer, I'm looking at you like the engineers at Dropbox who are building the storage. Anybody? All right, anybody else? Compress the data, distribute over several nodes. Okay, okay, good. So we have got the answers we have been looking for, and so I will move on. So this is the typical way we did it over earlier. What we did was use a network attached storage or storage area network, have 101 terabyte hard disk, and just a second, I'll just make a note of few things. Now, have 101 terabyte hard disks and make, I mean, connect them to multiple computers and then connect these computers together and you mount over the network, mount these hard disks onto a central place so that user can come to a central place and see that these hard disks are there and then start storing the data. Also also what you did was, along with each hard disk you put one more hard disk for the backup. That's the strategy we always follow in standard way, where each drive is backed up onto another drive. We call it RAID 1. Okay, we call it RAID 1. Now the question to you is, the question to you is it good? Do you see any problem with this solution? Do you see any problem at all? We just built this way. We took these hard disks, 100 hard disks, basically 200 hard disks. With each drive, there is one drive which is a backup of the same drive, and then connected to multiple computers, say 50 computers, two hard disks in each one, and then connected those computers onto a network, or maybe five hard disks in each, or 10 hard disks in each, and you connected them to 10 computers and connected those 10 computers in a network, and these hard disks are now available in the network and you mounted them as a subfolder onto a parent folder, and then you are letting users access it. Now question to you is, do you see any problems with it, or is it just perfectly great? Do you think it's just perfectly great and we don't need any other problem, we don't have any other problems with it? Okay. So Vivek's first question is, how will we search a movie in 100 discs? Good, good. So you make a plan saying all the movies starting with A go into drive 1, and B go to drive 2, C go to drive 3, and so on. Sampath's point is that RAID 1 is costly, but it is mainly for read only data like video streaming. You get better read performance. You're right. Yeah. SAN stands for, Balaji's question is what is SAN? SAN is essentially storage area network. Okay. Sampath's point is that we should use RAID 5 and so on. Okay. This is cool. Now the overall idea I was trying to say is that you just keep a backup of each drive in case one drive get corrupted, or there are bad sectors in one drive. You can start using the second one. All right. Now, good, good. So Vivek's question is, in case we have decided to put A, B, C, and so on, then what if all movies start with same letter? That's a very good point, because A Beautiful Mind, uh, there are so many movies starting with A or the in English, and therefore it doesn't make sense to have distribution like with the name of the movies. That's what is Vivek's point. All right. So, any other question, any other problems do you see with this kind of network? So, all we did was we connected these hard disk in the network and we started storing the data. So, one big problem was uh, how do we search the data? Where do we find the data? Any other problems do you see? Network latency. Network latency. Network latency means, uh, yeah. So, latency means it would take a lot of time to read the data from these disks. That's a good point, right? And any other problem? Underutilization of space in some disks, overfill of some. Very good point, Aditya. Thank you. And so basically, what Aditya is saying that some of the disks will get filled so quickly, while others will be empty, which is uneven distribution of data. Okay, so you have to come up with your own scheme of keep on moving files from here and there. Yeah, we will be keep. So Hari Prasad's question is, can we keep adding more movies? Yeah. So yes, we have to keep adding more movies every day. So we'll start with some 10 terabyte of movies, and then we'll keep on adding. And after say 5 years, we'll have 100 terabyte of storage. So Sampath is saying RAID 5 distributes the data across disks. So how many disks can you connect to RAID 5? What if redundant disk fails with primary? Okay, so the copy of the backup copy we are keeping with, if that fails along with the drive one, although the chances are low, yeah, so maximum 16, right? That is sample, but the thing is here we require more than 16. Or tomorrow if we have to go for 200 terabyte, how will we use the RAID 5? Okay. Any other problems do you see? I'm getting very great answers from you guys. Keep them coming. Okay. Sampath has got good answers. He says that create volumes each of 16. Good. And create RAID 5 in each volume. Okay. This is something. So Vivek's question is there only one main folder? And what if that one fails? Right? Yeah, that's a very good point. So in those cases, what we can do is on each of the servers which are hosting it, we can mount these hard disks in a symmetric manner. And then tell all the users that if one fails, then you can go to another one and so on. But again, if one server fails, then what? Yes, that's exactly the point of Vivek. Okay, so any other problems do you see? Sampath will take it up in when we discuss it, and then we'll take it up because let me also understand how does exactly RAID 5 work, and and then C. All right. All right. So do you see any other challenges with this kind of architecture? So there are basically for keeping the backup, the RAID is started for keeping the backup, and it seems that RAID does a lot more than that. All right. RAID is like redundant array of integrated disks. What is that? Redundant array of mm, what was the I stands for what? Sampath can answer. Independent disk. Redundant array of independent disks. Thank you, Sampath. So generally, for the backup purposes, we have the RAID where we write to one and RAID automatically duplicates the data. All right. So now, yeah, most of you have answered what I was looking for. So the first thing that comes to mind is failover and backup. In case any of this server on which you are running this data, if that network fails, then your data is gone. People cannot watch the movie if from that server, right? All right. And then, how would you distribute data uniformly? You will have to come up with your own scheme of things. You'll have to build something like an index server where you will keep index of which file is where. And as and when you move that file from one place to another, you have to keep on updating this index. And and that would require a lot of extra work whenever you are building such a system. So distributing data uniformly is going to be a big challenge. The other challenge is going to be, say you have a hard disk which is smaller than 80 GB in the network. But right now that's not the case. Okay. So your hard disk, your file which you're going to get stored is going should be always smaller than the size of hard disk, right? That's the assumption here. So, and therefore it's not always possible to distribute the data uniformly. Some servers will have too many movies while others will have very less movies. Because some movies, there will be a lot of movies starting with the, while there will be only few movies starting with q. Therefore the uniform distribution is going to be a big challenge. For that you might have to write your custom solutions, right? Now third problem is going to be is that with this kind of architecture, we bought 101 terabyte hard disks, we were pretty happy, right? But what if you already had so many small hard disks lying around, some 10 GB, some 2 GB, some 3 GB, some 5 GB, and so on? Can't you utilize those? Your answer is, if we utilize those, then we'll have to create so many folder, we have to manage so many hard disks, and we have to keep updating our indexes, we have to do this, we have to do that. And smaller hard disks, we cannot store bigger files. Therefore we have to buy these big hard disks. So your solution, this solution which we just described, is not cost effective at all, right? Third one is increasing accessibility. That is something which we all miss out. Increasing accessibility. Now, what does it mean? So a movie comes in yesterday. A new movie with a very very popular star comes uh, is available now. We put it onto the network, and now everybody wants to watch that movie. So the computer or the hard disk on which that movie is going to get stored is going to get thrashed badly, because 300 people trying to watch the same movie, they will choke the network, they will choke the computer, and the hard disk will die. most probably. Therefore, it does not it does not provide the accessibility. It does not provide a way of expansion. When the load increases, it basically kills the network, right? So it does not really provide the accessibility. Now, what about scaling out? What does it mean by scaling out? As I told you, that today we have 10 terabytes, and slowly, after some time, we have projected that after 1 year, we'll have something like 50 terabytes, and then after 2 years, we'll have 10 to 100 terabytes. Today, we have just few terabytes movies, right? Now, we need to expand slowly. Today we have only 10 servers. We want to keep on adding more machines, right? In case you have designed a plan saying that all the movies A is starting with A go on to this, B go on to this, C go on to this. In case you add one more machine, then you will have to reorganize your data. You have to readdress your scheme of what goes where, right? So scaling out, meaning adding more capacity horizontally, adding more machine, more server, more hard disk, is that supported by your solution? The answer is no. So therefore, or tomorrow, we instead of 100 terabyte, we got a requirement of 200 terabyte. How difficult is it to keep on moving from 100 terabytes towards 200 terabyte, one step at a time? Is that possible? Can we keep on adding one computer every day or every second day? Is that possible? So to answer that kind of questions, we are not ready yet. This solution does not cater to that. Did I make a point? So the answer is Hadoop distributed file system. It exactly caters to all these needs in a very seamless manner. It exactly caters to all these needs which we have just discussed in a very effective manner. All right. So are you guys convinced that we require a better solution? Probably Sampath wouldn't be. Okay, Sampath is also convinced, sort of. All right, I'm happy. And good. So anybody else, any questions as of now? And we can just move on to, then now I've just tried to prove to you that for Hadoop distributed file system, we require, for managing this kind of data, for storing this kind of data, we require a system, a file system which can handle petabytes, exabytes kind of data easily without having to bother. Right now we talked about 100 terabytes, but 100 terabytes is just sort of the beginning. It's a kind of space everybody builds in our organization, right? But big data demands even the far bigger storage, and that is little difficult for lots of people. Okay, so moving on. Any other question right now? Yes. So Vivek's question is, how would HDFS solve lower capacity hard disk? Quick answer is, it splits the file into small sizes. All right. So we are going to go deep down into the architecture of HDFS and how does it solve these problems. You will yourself figure out. Okay. Just keep an eye on these objectives, and you will have your answer. All right. So first and foremost, HDFS is a cluster. It's not a single computer. Hadoop distributed file system means the file system is distributed onto multiple computers, right? And there are multiple computers, and all the computers lie in two different kind of categorization. One is only one computer is a master one called admin node or name node. We'll refer to it as name node. Name node is the singular entity, which is sort of an index. As we talked about, that we'll keep an index somewhere, noting down which movie is where, and we'll just keep on updating this index. That's exactly what admin node is. While our movies are stored in each data nodes. Admin node or name node does not store the movies. It just notes down the file names, the folder names, their sizes, the permissions, and that kind of thing. So it's a sort of an index. Okay, it's sort of an index, but actual data is lying on each data node. Okay, so data node is the one which will have a lot of disk space, right? Admin node, name node keeps all of this information, indexing information into the RAM in the memory. Okay, and therefore you generally designate name node as somebody who is having a big RAM, while data nodes are somebody who has smaller RAM but have big hard disk. Okay, so effectively it's a sort of a master slave kind of environment where name node is the index where you keep the index, while data nodes are the actual storage places, right? Sounds cool to you? And what sort of metadata it is? So in other words, name node is a master of the system and manages the, we will talk about these things in detail. Now whenever user want to read the data, they read the data directly from the data node, asking name node about their locations. Okay. Now next feature is that the file that is stored in data nodes is split into a chunk of 128 MB. These are called blocks. These are called blocks. Each block is 128 MB. Earlier in previous versions of Hadoop, it used to be 64 MB. Now it is 128 MB. So every file you store onto a data node is 64 MB. Sorry, 128 MB blocks. So if you have got a file of say 1 GB, how many blocks are going to be there? Quickly. Good, good. So uh, good, Sampath. So there are going to be 8 blocks to store 1 GB file. All right. Now, if you have if you have 1030 MB, 1030 MB. Okay. If you have 1030 MB, how many blocks are going to be there? Anybody? Let me divide it by 1024 1028 128 MB. It shows that 8.024. So in those cases there are going to be 9 blocks. Okay, there are going to be 9 blocks. All right. So what? So these small blocks are essentially small files which are stored on each data node as a normal file under a particular folder which is dedicated to HDFS on of all these computers. And admin node, data node, what are these? These are essentially the network services. Okay, these are processes which are running on a particular port, which are listening on a particular port and catering to the commands on that port. Okay, so data node, name node, whenever we call, they are not hardware, these are processes. So you can run these processes on the same machine as well and different machines as well, but it always makes more sense if you put these services on different machines. Okay, now why do we what does it mean, how does it help in split, how does splitting help? First, it helps in fitting big files into small disks. Second, it leaves less unused space on the disk. How many times did you not realize that one disk was, I mean, I mean, you had to leave one disk empty while you could put more files into it. But since it was not fitting in there, you moved it somewhere else. Okay, so it's like big jars. You are trying to put big bricks into those jars. If the bricks are bigger, it won't be able to fit into that jar, and jars will be effectively empty, half empty. So therefore, it it helps you filling your disk space optimum manner, in a very proper manner, instead of leaving your data nodes half empty all the time. So Siddharth's question is, blocks can be smaller than 128 MB? Yes. So there are two ways to do that. One is you can configure HDFS. Second, when you are storing a file, you can specify that I want on 64 MB block size or 128, or say 10 MB block size. It's up to you. Okay. So the next problem splitting is solving is, it optimizes the data transfer. So these blocks, when the user is asking these blocks, it is, or when we are transferring the blocks from one node to another, or we are trying to rebalance, so that all these data nodes become in balance. Say we added more hard disk onto data node 1. Now we might want to rebalance the disk storage onto data node 1. Also, in case data node goes down at any moment of time, we'll have to move the blocks to somewhere else. So it makes it easier to transfer these blocks. Also, when user is asking for these blocks, we can provide that. Third is that it provides a great way of availability. You remember the problem where everybody wants to watch the same movie? Now imagine that that file is split in two chunks and is available in chunks onto multiple nodes. So first block is available on data node 1, second block in 2, third block on 3, and so on. So some users are using the first node, some are using the second one, some are using the third one, based on when did they come. Okay, if they are watching first 5 minutes of the movie, they are on the data node 1, and so on, right? So the whole bandwidth, the whole uh, the whole of our cluster is being used instead of only few. Okay, now this basically distributes the load to multiple machines. Now next is something called replication. Before I go for replication, let me answer a few questions. First is Sampath, read write requests are in terms of block size or like 4K. So those are standard way of reading from the network, and it's all up to the protocol which you are using. So the way you do a TCP protocol is read write the blocks, that is a standard defined by TCP. Okay, it will not be in terms of block sizes. We are not asking for blocks. We'll be asking that give me these bytes. First we'll go to the name node and find out where is our file located and on which are nodes, and then we will start reading from each machine. So we do not talk in terms of blocks always. What are the drawbacks of smaller block size? Thank you, Aman. Very good question. So if you keep on decreasing the block size, what will happen? Anybody else who can answer this? Anybody who can answer this? Index grows larger. Thank you, Siddharth. Excellent point. So yes. So when the block size you keep on decreasing, so what will happen is more and more information would be added to the index saying this block is lying on this data node, this block is lying on this data node, and this index will keep on growing as you are, as there are, say, if you have 1 MB size, right? So instead of one entry, there will be 1000 entries for 1 GB. Okay, or instead of 8 entries, there will be 1000 entries for 1 GB, right? So therefore, the index will keep on growing, and this name node runs on RAM. Okay, all of this index exists in the RAM, and hence the RAM will become the scarcity. There will be a scarcity of the RAM very quickly because you are filling the RAM with the index, right? So Aman's question is, or is 128 MB some kind of optimum block size? How do we determine what block size suits us? So, I mean, there are various hypotheses and various kinds of requirements. Now, it all depends on you. How do you want to divide it? The general thumb rule is you figure out that this is the file size which is accessed mostly on your network. Say you have got a 1 GB size of a movie, and that size of the movie is 1 GB. Now you have got 20 nodes in the cluster. Okay, 20 nodes in the cluster. So you can decrease your block size to something like 50 MB, right? So that one block exists on each of these nodes, and when users are requesting for the movie, they are uniformly distributed across the cluster, right? All 20 nodes are serving to the users, right? So that's one way of looking at it. But sticking to the standard 128 MB is good enough. And for that matter, the 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 default one that ships from open source has 64 MB, while Hottenworks and Cloudera both have 128 MB as the block size. Okay, so that's not something people are realizing that it's okay to have bigger block size, but there's no hard and fast rules. SBFS cluster should be identical in terms of hardware and software stack on top. Not really, not really. So as of today, the kind of time it is, Hadoop for we can run one data node on Windows, other data node on Linux, and other data node on Mac without any hurdles because it is built in Java and it runs on Java machine, and it is perfectly safe to run run it run Java machines across the network, across the different types, right? And the communication is not in terms of I mean a direct calls. Communication is through the standard SSH protocol. So effectively, it makes it possible to talk to various kinds of machines over the network. So index grows larger means metadata is growing larger in the name node. That was Siddharth's question. Okay, okay, so he was actually answered. All right. Now, does Hadoop allow removing the data? Yes, it does allow you removing the data. Block size, more number of inputs and less speed. Yes. Block size more, you can do one sequential write, which is better than performance. That's right, Sampath. So Sampath is saying if you have bigger blocks, it'll be easier to write on one disk because you are straight away writing your head. The hard disk head is not jumping here and there. You are straight away writing then and there. Writing in bulk onto a hard disk is faster than writing different files onto the hard disk of a smaller size. Okay, now we have, all right, does multi-threading concept apply here? Can there be a possible deadlock situation or a read write failure? How does, good point, thank you, Aman. Okay, so let me describe to you this way. So when you are writing a file, let me take it in a minute. Okay, let me just move on to this. What if we lose index node? Very good point. All right, so I'll take these questions after this slide, right? These are very good questions. And yeah, so replications. Other than splitting the data, there is added feature of HDFS that each block can have multiple copies in the network. So block 1 we can have two more copies lying on different data nodes, and in case in case one of the data node goes down, all the blocks that got lost on data that particular data node, they will their reproduction will happen. Okay, they will be recreated because there is a two copies lying in the network anyway, right? So each block on a data node has multiple copies. By default, the number of copies is 3, and we call this as replication factor. So by default, the replication factor of each block is 3. You can specify replication factor per file as well. Okay, as well as you can by default you can configure the system to set the number of copies, and also you can decrease or increase number of copies at later point of time once you have stored the data, right? Say for example you have got very important file, a smaller file, you can have 10 copies of it. Or there is a movie which is very popular which has come today yesterday, and you have hundreds of node empty, and you what you want is you want all the users, you want to distribute the load of this one all across the cluster. So what you do is you increase the replication factor so that each block is on multiple computers and can be served from multiple computers parallelly, right? So am I going faster? No two copies are on the same data node. That's a thumb rule. Unlike our the earlier system where we put the hard disk on the copy on the same node, it doesn't do that. Always the copy of a data is already on the another node. All right. Now if one of the data node fails, say there was block 1 which has 3 copies, block 1 got lost because data node there was a network connectivity problem at the data node 1. Now this block 1 will will now have only 2 copies instead of 3. So to match the promised replication factor of 3, Hadoop will start copying the data between data nodes to bring back the replication factor of the block 1 which we are talking about. Okay, so it's a very simple thing, that it promises a replication factor, certain replication factor to the end user, and it tries to maintain that replication factor. Okay, so that's what it is. Now the other thing is name node. is not the bottleneck. So typically the way people think about building such a service is there is this user guy and there is a name node. User guy will come to name node saying, "Hey, I want XYZ movie." Now name node will start reading it from data node and give it to the user. Now, if you see, this is a very very bad design. Why? Because why? Because name node is the bottleneck from all aspects: CPU, RAM, and the network connection. So name node is the guy who is the bottleneck out of all of this, right? This is fairly avoided like this. User comes to name node, it always think name node like an index and ask name node that where is my file. It name node tells that go to data node, and then the next step is it goes to the data node, reads the file, and start watching the movie. Happy? Good. Now let me take up the questions. Does multi-threading concept apply here? Can there be a possible deadlock situation or read-write failure? How does Hadoop handle it? Good. So now think of this way. There is definitely a deadlock situation or inconsistency situation in that there is a file 1. User 1 came to create that file. Now user 2 came to read that file. Now if name node is not smart enough and the client, and here also note that it's not you as in you per se, this is basically the client you are going to use, the command line, the driver, just like you have Java driver or ODBC driver. Similarly is the driver you're going to ask this to do all of this on your behalf. Okay. Now in case this user is writing data to the name node will mark that file as uncommitted. Okay. Now, unless you finish it, it won't be serving it to anybody else. And therefore, it avoids all those inconsistency issues as well as multi-threading or deadlock or race conditions by using the locks on the name node. Okay. So whenever the user is, there could be thousands of readers at the same time onto the file, while there could be only one writer at a time. Writer and reader cannot go parallelly. So those are the kind of optimizations and safety Hadoop has taken into consideration. Now, next question from Aditya is, what if we lose index node? That's a very good point. The name node, in case you lose the name node, what will happen? So the general architecture is we always keep a passive copy of name node which is ready to be to come to the life, right? Therefore, it is quite safe. So the moment name node goes down, we just replace it with the copy which we are keeping. Every time user is writing to the data node or user is writing to the name node, the same changes are being made to the other machine who is going to be the backup of name node. We call it backup name node. Or there used to be some a concept of secondary name node, but people don't use that secondary name node anymore. How is processing of data done like any sort of sorting or searching techniques? Good. So the sorting and searching, the way it happens is we ask the user asks for sorting, and name node, similar to name node, there are task trackers, and that task tracker asks all the data nodes to do the sorting because data is lying on the data node, and these data nodes will sort the data for you and give it back to you. And that's what is called map reduce and yarn framework. We'll take that up in the next session. Okay. Is max 16 copies limit? What So not really. I mean, replica factor can be anything. It's not only 16. Okay, I haven't at least read about 16 as the replication limit. Okay. Yes, replication factor can differ per write. Means every file you are writing to the to HDFS can bring its own replica factor. Yes. So Ankush's question is, keeping three copies is not necessary. Would two copies will not be sufficient? Yes, you are right. So for example, on our network, the cloud labs which we keep, when it's a project work, all the data has a copy of some data which is fairly redundant. We reduce its replication factor to 1 instead of 2. Okay, instead of 3, while some of the data which is fairly critical, we keep a 3 copies of it. Okay, so Sampath's question is, HDFS cluster has private interconnect which connects TCP/IP, or it supports InfiniBand FC clutter, uh, or FC clutter interconnects. So it's as simple as that. If you can telnet from one machine to another, you can use Hadoop. Meaning it works on TCP/IP standard, and specifically over SSH. So all communication read write happen over SSH. There can be some situation where data is required is combination or kind of join from node 1 and node 2. Is it possible in HDFS? In those cases, you will have to build your solutions accordingly, and that is going. I mean, that's a little tricky situation mostly. So Ankush's question is, in those cases where you might have to join the data from node 1 and node 2, and is that possible? Of course it is possible. It is just that on the system on which you're joining these two data, you need a disk space which can accommodate both the sizes. Or else you will have to build really clever solutions such that there is a minimum data transfer, such that you transfer the data from node 2 to node 1 instead of node 3. Instead of copying the data from node 1 and node 2 to a third node, you copy the data from one to another. That's actually possible. What if a file has to be distributed in two nodes? How can it be maintained in name node? If a file has to be distributed in two data nodes, how can it be? So that's how it maintains. So if a file is divided into into blocks, and name node keeps a track of which file is where, or which file is on which all data nodes. That's how it does. Not all nodes in the network has same latency. Can HDFS use that to its advantage, storing more requested blocks on nodes with lower latency? Right. So that's a very good question, Siddharth. So his point is that instead of uniformly treating all nodes alike, can HDFS take some into account the nearness or farness, I mean nearness or the high bandwidth, and utilize or optimize the traffic? It does, in fact, just that it doesn't automate that part. It relies on you to define the network topology, and accordingly it uses that topology to take a lot of decisions, such as when it's creating the block copies, it always creates a copy onto the same subnet, and then the third copy is somewhere very far. Okay, if the data nodes are not identical in hardware, say each node is having a network speed different, how is the speed ensured to there is no ensurety about consistency of speed. It's not it's not there. Okay, and it doesn't promise that. It works on disparate networks. It works on disparate hardwares, and that's the whole objective of running any big data solution. So Vivek's question is, would replica help in load balancing? It does. It does. Yeah. So his exact question is, if we have replica parts available, if there is a movie which is quite popular, if we increase number of replica, will it help the users who are watching the movies? Yes, in fact it does, and that's very important aspect. So user can read from the backups or the replicas. Okay, I'm sorry, I just jumped backwards. All right, now not all nodes in the network has same latency. Good. All right, great, great. So all questions answered. If you have any questions, feel free to ask. All right. Now that's about our HDFS, and we have covered almost everything what we have planned for HDFS. All right. So this was again the say all the components, and the flow diagram is already covered. Is it something we decide or happens automatically to read? It happens automatically. Okay, we can read from the replica. We don't specify because replica and the main one are identical copies. There is no difference. So it doesn't make any sense to be specific about replica or the main one. Okay, so that's about HDFS. All right. Now I have few things to tell about ourselves. So those guys who will be who have already purchased and are attending this session, they can go to our Cloud Labs. And what Cloud Labs is, it's basically a cluster with all the technologies already installed for you, which is accessible 24 hours and from anywhere in the world. Okay, and basically you don't require any other hardware to install on your laptop, or you don't have to increase your RAM, or you don't have to buy another hardware to access this cloud lab. You can simply SSH or use the browser. Okay, now those who have already taken the course, they can log in into their LMS and go through the quiz and finish the quiz, and and see the assignment sections in the LMS also. Okay, and if you can see the Ambari console, we are using Hottenworks as our Hottenworks along with the Ambari and couple of more tools to manage everything. And there are various consoles available. Admin, one is Ambari, which is admin console. Who is basically interacting with various services. SSH is the command line one, so you can go there and use. And those who have not bought the course, they can buy the rest of the course. There are total 11 sessions, 33 hours, and this is the price. Okay, if you have any questions, just drop us an email. A better thing would be reach us. Okay, a better thing will be reach us. All right, reach us at nobigdata.com, and this is the phone number. All right, and also you can go to the website and raise a query there. It takes the same time for us. All right, now okay. So Ankush's question is, I'm an Oracle DBA. How helpful for me is this training and big data? I think it is quite helpful because uh, there's a correct path for mainframe developers, Oracle DBA, and Java developers, all three kind of people, to move into big data and and basically understand it. Okay, and also note that the typical DBA is not equal to Hadoop administration. The people from sysadmin background can go for Hadoop administration, but people from DBA background, they should ideally be going for Hadoop developer course, because their main role has been churning the data, not only the installations. I am into QA testing. Will Hadoop help me? Also, is Java mandatory? So, first, if you are in QA testing, because QA is a very big role, okay, and everybody expects QA to know every other tool available in the industry. So it becomes imperative for QA to learn these new tools, because invariably, wherever you are working, you will end up using these tools in next years. This will be like omnipresent, okay. So it is inevitable. Second is that, is Java mandatory? The answer is no. But for this course, this particular course, you should have some experience in programming, even if it is 10 years ago you have coded something or you have worked on something. Okay. Because the concepts, if you are okay with some programming language, it's it's easy to gain the concept, okay. And also the map reduce part, which required Java traditionally, what we have done is we have converted map reduce into a proper paradigm rather than a programming language specific thing. So we demonstrate you how to code map reduce in shell, in how do you build a logic behind, how do you convert a problem into map reduces using a pseudo language. So we have done that kind of innovations in the training part. So Ayushi's question is, how do you get into research project in Hadoop? The easiest thing would be you just join the Hadoop community, and you just pick up something which you find really interesting out of to-do list on their wiki, okay. And then you will, if you really do good, they will consider you in the main committee. How to start project on sentiment analysis? How to start a project on sentiment analysis? I am an engineering student. So start a sentiment, just the easiest thing would be for you is just search for sentiment analysis using Hadoop and Flume. You will get couple of available, um, you know libraries. You can go through those projects and then start working on it, okay. Although the idea is pretty straightforward, all right. Idea is pretty straightforward. Download dictionary containing words and words and their meaning, whether negative or positive, okay. And then you apply those negative positives on each tweet which is there. You create a Twitter account. In the Twitter account, you can just download the API key and then access Twitter using Flume and download the data. It's as simple as that. Yeah, next session onwards is a paid one, and I'm doing it full time. I'm not doing it part time. So therefore, I too have to earn something. Okay. Okay. So Anoop's question is how, and the topic you suggested about movies in hostel too is a good topic. How to really go about it? Easiest thing would be just buy two computers or just buy one computer, set up Hadoop, set up HDFS, and start uploading movies. Okay, and then keep on adding more and more data nodes. But start with two computers at least. Okay, start with two computers. Only then you will get a feel of it. If you have two old computers, you can start working on that. You build it in your own home. Okay. So any other questions? Are there anything you recommend, suggest to refer the information security with big data analytics? I am an information but new to this field. Good. Good. So probably a good way to look at it is the understand what are the common flaws people leave. One is the way people you build you basically you can actually publish the set of guidelines and understand set of guidelines with respect to security. Understand what are the set of guidelines to set up a cluster which is secure and and so on. Okay. The other thing you could do is you can take up any service like a zookeeper and do a code review. When I did a lot of white hat hacking in that sense that I used to edit open source product such as Liferay I have audited, I have published those reports and those are quite popular actually. Okay. So you can do those kind of things also, right? So Ankush's question is, how can you compare with Oracle database? Oracle database also has clustering system and also works on distributed application. The problem lies in the throughput as well as the scale. Okay, Oracle is yet to build that kind of scale which is required in these systems. When you have to handle some 500 terabytes of data, then it becomes quite difficult. Okay. Also, they might have declustered the storage, but still, in heavily consistent systems, there is always there is always a bottleneck. So theoretically, if you look at the CAP theorem, Oracle cannot be able to beat in performance any of the NoSQL servers. Okay. So Siddharth's question is, how is NoSQL related to Hadoop and big data? The quick answer is no, it is not. NoSQL is it just so happens that Hadoop too has something called HBase, which is a NoSQL database, which is based on a paper published by Google called Bigtable. Okay, so NoSQL is nothing but a database undone. It's not a database done; it's database undone. They remove transactions, they remove lot of things which basically consume a lot of computing as well as which make it impossible to distribute the computing. That's exactly what was done in NoSQL. So Vivek's question is that do you have in-class training too? I mean in person? No, we stopped it completely because the performance we observed in the in-class students was pathetic. Our online students were performing at least 3 times better than offline students, so we stopped it. There was no point. Oracle RAC is not scale out architecture. Okay, thank you, Sampath, to support my point. Okay, all right. So, any other questions, or we call it a day? Ankush, you got the answer. Good, good. All right. So, feel free to reach out to us either at sandeep@nobigdata.com or you visit our website nobigdata.com. And if you have any questions, just drop me an email. All right, or give me a call on this number. All right. Thank you very much. I hope you enjoyed it. I hope it was not just another big data session and you learned something from it. I'm hoping that. And okay. Thank you, Sampath. I'm happy that you like it. Thank you, Siddharth. I'm glad that you liked it. Okay, good, good. So Hari also find it useful. Good. Okay. So Anup also liked it. Good. All right. All right. Thank you, Balaji. Have a good day. I'm happy that you found it useful. Okay. So Aman says that it was awesome. Okay, I'm happy. I'm very glad. Okay. Thank you, Ankus. I'm happy that you found it very good. Okay, then have a good day. Okay. Feel free, I'll be sending you the presentation and the recording by morning. And feel free to share it with your friends. The recording and the presentation, you're free to share. It's okay. And in case you're interested in going for the class, you can go for the class. It covers around 13 topics, similar to SDFS, MapReduce, and all other things which are required for this domain. It covers everything with standard hands-on exercises. Okay. And so far the feedback of Cloud Labs has been marvelous, and you'll get to actually feel that how to work in the cluster. All right, then, have a good day. Bye bye. Have a good day. Bye bye. Great. You're a great set of audience. I totally enjoyed your questions.